All right, guys, welcome to 7.4 Notes Completion via video. And today we're talking about special types of parallelograms. So the last two sections we've been focusing on the properties of parallelograms and like opposite sides congruent, opposite angles congruent, diagonals bisecting each other, etc. And today we learned that there are three shapes that you guys are familiar with that fall under the parallelogram category. So important to note that these three shapes that we're talking about here, and we've got rhombus, rectangle, square, they are parallelograms. So everything that applied to a parallelogram also applies to these three. Opposite angles congruent, opposite sides congruent, etc. All right, but now there are going to be some more specific things that occur here with these three shapes. So let's take a look first off at the basically the definitions of these three. A rhombus is a quadrilateral that has four congruent sides. All right. A rectangle is a quadrilateral with four right angles. And you can see the phrasing of these: if and only if, biconditional. So they go both ways. It's if it has four right angles, it's a rectangle. If it has a rectangle, it has four right angles. Let's see here. Then the square is basically a combination of rectangle and rhombus. If it does each of those two things, then it's a square. If and only if. So it's a square if and only if it's a rhombus and rectangle. And if it's a rhombus and rectangle, if and only if it's a square. All right. So now, to understand these a little bit better, a Venn diagram. Thanks to John Venn, we have these pictures that help illustrate and keep things straight about, the criteria of various things in the world of mathematics, in this case, shapes. So in this entire rectangle, we have the world of parallelograms. So parallelograms, opposite sides are parallel. Now, inside that, we have a couple different things. We have the three special p-grams we're talking about today: rhombuses, rectangle, square. And you can see the overlap of rhombus and rectangle is a square. So basically you can break it down like this: like some parallelograms are rhombuses, some parallelograms are squares, some parallelograms are rectangles. Some rhombuses are squares, some rectangles are squares. Let's see what that means here with these always sometimes questions. Example 1. For any rhombus QRST, so we got a rhombus Q, R, S, and T, decide whether the statement is always or sometimes true. So this first one, Q and S are congruent. Well, since a rhombus is a parallelogram, all parallelograms have opposite angles congruent, so this is always true. If it happens to a parallelogram, it's going to happen to a rhombus. Part B. Now this one's a little tricky. Q being the same as R. What do you think about that? Well, are there any rhombuses that would have the angles next to each other being congruent to each other? And of course, the world of squares would be that case. But not all rhombuses are squares, but some of them are. Some rhombuses are cool enough to be squares. You think about the rhombus oval in the Venn diagram. Some of those rhombuses are squares, because all you need to do to be a rhombus is have four congruent sides. So squares have that, and then they have more than that. So to ask, hey, are the side-by-side angles congruent? Well, only if it's a square, which in some cases, rhombuses are sometimes squares. All right, example 2, classifying a special quadrilateral. Classify this one. If you have a picture marked up like this, we've got four sides congruent. All right, so it's at least a rhombus. Could it be a square? Well, the 70 is here, to let you know that it's not a square. And so, or obviously a rectangle, because you'd have to have 90s everywhere. So to classify this as specific as possible, we would say this is a rhombus, which of course implies that it's also a parallelogram and a quadrilateral, but you can just go as far down the list as you can go is an answer. When you call it a rhombus, it's implied that it's also a parallelogram. Cool. All right, pause the video here and see what you come up with. You might want to sketch these out and see what you got. All right, back again. Da-na-na. For any square, JKLM. So let's sketch it. So we got a square JKLM, and of course it doesn't matter where you start your J as long as you go in the order with which they wrote the letters. It's a square, so I know that I got 4 right angles and I have 4 congruent sides. It is always or sometimes true that JK is perpendicular to KL. Well, since it's a square, that is always going to be true. You have right angles by definition of a square. All right, the next one. For any rectangle, so let's draw a rectangle. E, F, G, H. So what's a rectangle mean? You know you got that happening. And of course it's a parallelogram, so you have the opposite sides congruent. It wants to know, is it always or sometimes true that FG is congruent to GH? All right, well, think about this. Could this ever be the case for a rectangle? Could you ever have the sides, and you can back it up. Think about your Venn diagram. Do any rectangles at all in this whole oval have the sides next to each other congruent? Sure, the ones that are inside the square bubble. But that's only some of them. That's not all of them. So some rectangles actually have all their sides congruent, aka are squares. So again, you can use the Venn diagram. Just think, are any rectangles at all, do any rectangles at all have the same sides all the way around? Sure, this little part here, that is the squares. And example 3, or monitoring progress 3. Quadrilateral has 4 congruent sides and 4 congruent angles. So if it has 4 congruent sides and 4 congruent angles, it's gots to be a square. All right, moving along. Oh, now each of these special parallelograms have some things happening. They have their own theorems. Rhombus gives us 2 theorems. Rhombus diagonals theorem, which tells us that its diagonals are perpendicular. So very important. It also tells us that each diagonal will bisect a pair of opposite angles. So essentially, in a rhombus, you've got 90 degrees for the central angles where the diagonals intersect. And then you've got 4 angles that are all the same at those 2 vertices and 4 angles that are all the same at those 2 vertices. So let's see what it looks like with an example. It'll be a little easier to illustrate here. Find the measures of the numbers angles in the rhombus. So they start you out, big old rhombus. We know it's a rhombus by getting the given, so all the sides will be the same. They give you one thing here, 61 degrees. We should be able to find every other angle. And of course, angle 1 in the middle, we know where the diagonals meet for a rhombus. As soon as you see rhombus, you know that you have 90 degrees. So the measure of angle 1 is 90. Bada bing. 90 is all the way around the middle. Now, the other theorem told us that the diagonal will bisect a pair of opposite angles. So like for this AC right here, it's cutting this big angle C in half. So if there's 61 on that side, there's 61 on that side. There's also 61s for angles 2 and 3. So the measure of angle 2, 61 degrees. The measure of angle 3 is 61 degrees. Now you can probably guess how we're going to get the angle 4. If I take a look at this triangle blow it up a little bit. I got the 90 in the middle. I got a 61 right there. So that's going to leave you with 29 degrees using the 180 concept. So the measured angle 4 would have to be 29 degrees. That's what's left out of 180. So you can see how you can split the rhombus up. Now in the monitoring progress, it's a little different. So let me see what you guys come up with. So pause the video here and see what you got. All right, back again. A couple different ways to do this. So in example 3, it wants to know what is ADC, A to D to C, and B to C to D. So they just want the big angles. And of course, ADC is just, so we had 29 right here. So just double it, and that would be 58 degrees. And then BCD, this big angle is double 61, and you'd have 122 degrees. All right, now for 5, a little different here. Now, some of you may have gone like this, busted up G to E to give you 2 separate diagonals there, just like we had up in the picture up above. So we did that. You'd have to break the 118 in half. So that would give you 59 and 59. You know you got 90s in the middle because it's a rhombus. So 59, so that would be 31 degrees left in the triangle. So 31s for all of these angles right here. So they would all be 31 degrees for measures of angles. 1, 2, 3, and 4. Now, maybe some of you guys may have gone like this, and I just want to show you another way you can do it. And you didn't really necessarily have to draw in the other diagonal. You could do it like this, like this. It's a rhombus. So think about it. You got a big old isosceles triangle right here. So you could have just taken 118 off of 180 and get 62, then divide that in half to get 31 and 31. And now, since remember, a rhombus is a parallelogram, so the opposite angles are congruent. So whatever you have at G, you're going to have at E. So all these things are coming back into play for parallelograms too. So this triangle will mirror this triangle. They are congruent, as the French would say. So either way you want to do it, fine by me. All right, rectangles give us one separate theorem as well, and it is that the diagonals are congruent. All right, so the A to C is the same as B to D. Rhombus doesn't have that, of course. You think about a rhombus, it could look real exaggerated, like one diagonal real short, one real long. But they're perpendicular, as opposed to the rectangle does not have perpendicularity happening where the diagonals meet. And again, that's pretty easy to see. So if you're stuck on an SAT and you're like, man, I can't remember, like just draw it out. Like, you know, they're not 90, they don't look like 90s there. That's the beauty of it. Whereas anytime you draw a diamond, it's going to look like 90s in the middle. All right, so rectangle diagonals are congruent. All right, example 4. You're building a frame for a window. The window will be installed in the opening shown below. The opening must be a rectangle. Given the measurements, can we assume that it's a rectangle? So if I just look at this, I got 44, 33, 44, 33. Is that enough to say that it's a rectangle? Unfortunately, no, right? Because parallelograms have their opposite sides congruent. And that's really all we got right now. We know that the opposite sides are congruent. We can't judge by, man, it looks like it, but based on the measurements, we don't know enough about it. We know it's a parallelogram, but that's all we know. So we'd have to say, no, we need more info. So then in part B, we measure the diagonals of the opening. So they're like, all right, well, this is a way we can tell if it's a rectangle. I measured this diagonal And this diagonal, I get 54.8, I get 55.3. Egads, man! What can we conclude about the shape? Well, it's not a rectangle because our diagonals are not congruent. That is not the same as that. So all it is a pentagon. Can't be a rhombus because the four sides are, I don't have all four, so it can't be a square. All it would be a parallelogram. Not good. We want it to be a rectangle for this opening, so we would have to do a little bit more work. We'd have to alter the angles a little bit. And that's a good way, if you ever want to see if you have a rectangle, if you're building anything, just check your diagonals and see if they are congruent. And finally today, wait, two more examples. Example 5, we've got in a rectangle QRST, so they're telling you it's a rectangle, so we know that QS would have to be the same length as RT. So I can just take the two quantities they gave me, 5x minus 31, and set that equal to 2x plus 11. So solve it. Subtract 2 x's on both sides, add 31 to both sides, and x would have to be 14 when you divide both sides by 3. Find the lengths of the diagonal. So then plug it back in. So 2 times 14 is 28, plus 11 is 39. And you could double check over here. 70 minus 31, 39 as well. So the diagonals are 39 long. And our final example today, identifying a parallelogram in the coordinate plane. Decide whether, so you know it's a parallelogram based on that symbol, gives you the vertices, is a rectangle, rhombus, or square. Now, the quickest way to do this, to eliminate some stuff, first off, look at it, and it doesn't look like it's going to be a square or a rectangle, but let's just get it out of the way for sure. So, let's see. What makes something a rhombus? What makes something a rectangle? What makes something a square? So there's a lot of different ways to do it. Same way we did last section with determining if something was a parallelogram or not. So if we look at the diagonals, that might be your fastest approach. If we look at these diagonals, we can check to see what their lengths are. If they're not the same length, then that rules out rectangle and square. Then we can check to see if they're perpendicular, then that would make it a rhombus instead of just a normal parallelogram. So I'm going to check AC's distance first off. So distance formula, I take the changes in the x. So 4 minus a minus 2 is 4 plus 2. Square it. Then the y value, 0 minus 6. Square it. So 6 squared is 36. Plus negative 6 squared is 36. So this is the square root of 72. And really, guys, you don't really even have to break it down any further than that for this. You're just checking to see. Now let's check BD. Next chapter, we're going to simplify radicals, but for right now, you just want to see if they're equal. So now let's see how B to D changes. 6 minus a minus 4. So that's 6 plus 4 squared. Then the y values go from 8 to negative 2. So that's 8 plus 2 squared. So that's the square root of, let's see, 10 squared is 100 plus 10 squared. So this is the square root of 200. So by showing me that, you know it's not a square or a rectangle because the diagonals are not congruent. All right? So now let's see if it's a rhombus, and we just talked about rhombi. I wish I could roll my R's. Rhombi. They'll have perpendicular diagonals, so let's check the slopes. Let's check the slope of AC. And the slope of AC is rise over run, so 0 minus 6 on top of 4 plus 2. Negative 6 over 6 is negative 1. So that's my slope of AC. So then I'm going to check the slope of BD. And let's see, on top, rise, I'll have 8 plus 2 on top of 6 plus 4. Oh yeah, this looks good. 10 over 10, which is 1. So you know that that means they are perpendicular. So therefore, this indeed is a rhombus. It has perpendicular diagonals that are not congruent. So you're just going to show me work for these things. And diagonals are usually the easiest way to go. So we'll practice some more of this for our homework and our in-class days. So that's a wrap on Section 7-4, party people. Rhombus, rectangle, square. Peace!